Okay, so with DFS, this is the visualizer. And so usually when you're looking at a graph, the way that we read in English is top to bottom, left to right. And so that's how we would read this. So we could argue that DFS search, if we assume the top is the root, we start at 0, we go to 2, the first child, like quote unquote first child, would be 1. The first quote unquote the first child of 1 would be 5, and then 3, and then we go to 7, and then we go to 6. The child of 6 is 1, but we already visited 1, so we would be done, and then we would do go back to the next child of 2, since 0 doesn't have any other children, which would be 4. So when you visualize it, that's sort of what it looked like. It may or may not follow this order based on the internal representation. So let's see how it says that it goes. So it goes from 0 to 2, which we said, to 1, to 5, to 3, to 7, to 6. One's already been visited. All the children have been visited already, except for 4. So then I'd go to 4. So it follows the order that we visualize. So let's see if we can get a graph where it doesn't follow that specific order. Actually, it might be easier with a directed graph. Okay, here. So the way we're reading this, right, if we're reading from left to right, we would say it would go from 0 to 3, and then, 3 doesn't have any children. It would go to the next child of 0. So it would go to 2. 2 doesn't have any children. And so that would kind of be it. Let's see if it does that order. So it actually goes to 2 first and then to 3. And the reason it does that is because if we look at the adjacency list representation, it's actually storing the list of children in increasing order. And so we visualize it here, and again, we start with 0, we'll see that it visits each one in the order it appears, which is first 2 and then 3. And we can see this actually in the matrix as well, where it goes to 2 first, and then it goes to 3. And so what matters really is this internal representation of how it's stored on the computer, much more so than the way we would view it, right? Because a graph in reality isn't stored like this on a computer. This is just the way we visualize it so that we can understand it as humans, but the computer is really going to be reading it represented as this or this. And so if it's in a matrix, it's going to necessarily be in increasing order. If it's an adjacency list, it depends on how you build it. So it may or may not be in increasing order, but more likely than not, it is.